Hello. In this video, I would like to say something about how to make the output become 16-bit resolution. Okay. I make it like this. This is the OCR1A PWM output. I pass this output through a low-pass filter, and the frequency is set at 27.2 kHz because it is constructed by a 3.9 kilo-ohm resistor and a 1.5 nanofarad capacitor. The OCR1A actually store the high byte of the wave file. It decode the high byte, okay, and the OCR0A decode the lower byte. So they combine become a 16-bit. And the resistor here is 1 mega and 6.8 picofarad capacitor here. It also forms a low-pass filter, and the cutoff frequency is at 23.4 kHz. Then why the value here is 1 mega and 3.9 kilo-ohm here? Because the 1 mega and 3.9 kilo-ohm form a ratio of 256. Okay, and I combine the output here, and there is a 1.5 kilo-ohm resistor to ground. It forms a potential divider, and the output here goes to the PC line in is at most 0.8 volt. Okay, so I think this is good enough. Okay, now assume I have to handle a 16-bit 44 kHz wave file, and in this program I have to use a 18 megahertz crystal. The 16 megahertz is just not fast enough, so I change it to 18 megahertz. Then for a 44 kilohertz wave sample, I have to set the ICR1, ICR1 to 408. Okay. Then let's see here. The ATMega168 have 3 timers. The timer 1 is 16-bit, but timer 0 and timer 2 are 8-bit. So the timer 1 is set to PWM mode 14. The top is 408. So the counter count from 0 to 408 and then come down and 0 and go to 408. Just keep on. Then the timer 0 is also set to PWM. It's mode 3. And the top is 255. And I use timer 2 to make some control about timer 0. And timer 2 is set in the CTC mode, and its top is defined by the value in the OCR2A. Now suppose that we set an appropriate value into the OCR2A. Then assume a value of 240 feet here. When the timer 2 compare A, fire up, because I set here OCR 2A. So when this interrupt fire up, I just stop timer 0 and timer 2. Hopefully, when this interrupt fire up, the timer 0, the counter of the timer 0, that means TCNT 0, is somewhere around 250 feet. Okay, and in this interrupt routine, it stopped the timer 0 and timer 2, and it write some value from the buffer to the OCR1A, OCR1B, and OCR0A, OCR0B. And those values would be updated when the TCNT 1 equals 0 and TCNT 0 equals 0. Okay, and then it also set the TCNT 0 to 254 or 53 or somewhere around this, and the TCNT 2 set to 0. Okay, so now we go back and see what happened here. When the timer 2 interrupt fire up, it stopped the timer 2 and timer 0. Okay, and then we update those 4 values. What are we going to do when timer 1 overflow? We also set an interrupt here. You just simply start the timer 0 and timer 2. Restart those 2 timers again. But of course, it also update those 2 values. Then set a new value for the PWM output for the next cycle. Okay, so this story go on. It just keep repeating those things, and actually I get a 16-bit resolution from such thing. Okay, this is the whole idea, and the actual hardware is just something like this. Here is the OCR1A. Okay, so it passed through this 3.9 kilo ohm resistor, and then here is the 1.5 nanofarad capacitor and pass to ground. Okay, and then there is another 3.9 kilo ohm resistor. Okay, and here I got the OC0A here. Yeah, OC0A. And here is the 1 mega ohm resistor, and this is the 6.8 picofarad capacitor. And then there is another 1 mega ohm resistor. And here is the 1.5 kilo ohm resistor to ground. Okay, so here is the combined output that fit to the PC line in. Okay, that's the hardware that I use. Now for the software, what I'm going to do is a little bit simple this time. So remember that in this program I use 18 megahertz crystal. Okay, I already changed the crystal in the development board, so I start the AVR Stidio 4. Okay, new project, AVR GCC, and okay, and I already make a new folder using the name here, so that's alright. I select the microcontroller. Okay. Oh, not yet. Okay. Yep. I got a new folder here. Okay, but I've forgotten to make a copy from the PWM. From RAM. Okay, I have to copy files from RAM. Okay. It's here. Okay. Okay, I got it. And okay, that's alright. So now I add those files to the project. Okay, and add those files to the project. Okay, and then I set the crystal frequency. This time is 18 megahertz. Okay, and then main.c. Okay, let's try to build it. Okay, it's alright. And now I have to make some changes. Okay, I have to add two variables to the byte here. There's a byte variable. Okay, that's good. Okay, now I change the two interrupt routines. Okay, so they are here. Okay. Okay, not here. Okay. Okay, that's good enough. Okay. So I got those two interrupt routine repasted. Okay, that's alright. And then I have to replace the RAM up and RAM down, because the RAM up and RAM down here doesn't control the. Yep, it already controls the timer 0 and timer 2. Okay, forget it. However, I would like to replace those two. Okay, it doesn't control the TCNT1. Okay, so I just replace those two functions. the RAM up and RAM down. Okay. Okay. Now we paste it. Okay, that's good. And then I have to repaste something, and starting here from the start page. Okay. Okay, I delete it. Okay, and I make copy from here. I got start page. Okay. What I'm going to do? What's wrong? Okay, I'll start from here. Okay. I make copy here and I paste it here. Okay, I compile it, and now I upload the program. Okay, that's all right. And now I make a test about the result, and I change the setting here. Just a line in. Hello. I just played a 44 kilohertz file, and now I would like to try a 22 kilohertz 8-bit mono. That means the slowest wave file playback. Okay, let's see what will be the result. Okay, I got my voice. Okay. I hope that you can hear that. The playback for the 44 kHz 16-bit stereo sounds good. It also works for the slowest 22 kHz 8-bit mono file. It also sounds good. Okay, so actually it works quite good. And here I would like to say something about the program. Okay, here why the timer to compare a interrupt fires up, it slow down the SPI interface first, okay, and then I take a record. Yep, it slowed down the SPI interface, and then it stopped the timer 0 and the timer 2. And I also make a record about TCN T0, the counter, timer 0 counter, okay. And then according to the mode value here, it means the mono 8-bit, stereo 8-bit, mono 16-bit, something like that. It read value from the buffer, and then they write the appropriate value to the OCR1A, OCR1B, okay. And for the 16-bit wave file, it used the timer 0 and the timer 1. So how to do it? Okay, I use the 16-bit stereo as an example, okay. Because I have to set some margin for it to work, so I set the margin as 250. Don't be too ambitious. 255 would not be a good value. So read in the value from the buffer, okay, and check if this value is larger than 250, then set it as 250, okay, and then write it to OCR COA, okay. And then the next byte read in is the high byte, so add a 110dx to it, and then write it to OCR1A, okay. And then it comes the right channel data, okay. Check it and set it, ensure that it is the largest value for it is 250, and write it to OCR0B, and then the other byte is the high byte, so add 110dx to it and write to OCR1B, and then set the TCN T2, the timer 2 counter, as 0, and set the timer 0 counter as 253, okay. And here, this is the trick to finish the playback. When the read index and the write index is too close, that means they differ by less than 64, then slow down the SPI clock rate. If they are larger than 64, then the SPI clock rate run at full speed, okay. That's the control. Okay, how to set the value for the OCR2A? There is something here, okay. After we get the the required data from the header, okay, header of the wave file, that means we now know the frequency, the 8-bit or 16-bit, mono or stereo, such thing. Then we start to set the PWM mode or something like that, okay. So at first I removed all the old settings, okay, and then I set the PWM mode, set it as mode 14 for the timer 1, okay, and set the interrupt. You set the overflow interrupt here, okay, and then I set the ICR1 value, that means the top value for the PWM. Okay, and then reset the setting for TCCR 2. Okay, and also the TCCR 0. Okay, and then set timer 2 in the CTC mode and set the compare A interrupt. Okay, because the TCCR2A is 0, so the output pin is disconnected. Okay, and here I set a value 254 to the OCR2A. It fits for the 8-bit wave file, and I set a value here, a OCR2A calibrate. Okay, I set it to 1. That means there is no need to modify it, no need to change it. And now we test if it is needed to be modified. That means it is not mode 0 or mode 1. It is mode 2 or mode 3, so mode greater than 1. The mode value here greater than 1. Then I set the OCR2A to 200 and set the OCR2A calibrate to be 0, and then I set the timer 0 in the PWM mode. This is the mode 3. Okay, and the top is 255. And here I got something here. Okay, if the OCR2A calibrate is 0, that means this is a 8-bit wave file. No. When the OCR2A calibrate is 0, that means this is a 16-bit wave file, and the value in OCR2A has to be checked. So now I compare the TCNT0 recorder value with 252. Okay, because at the starting I set it as 200, so I checked it. If this is smaller than 252, I increase it, and if the value is not smaller than 252, that means it is already 252 or 253 or something, then the calibration is done. So I change the OCR2A calibration to 1. Then I don't have to check it in the next cycle. Okay, and actually this is the whole idea of the program, and it works good. Okay, the video is going to stop here. Okay, thank you very much.